Hi, I'm Tom. When I left you, I was saying this. So far, it seems that there's no amount of people, really, that the Hilbert Hotel can't fit in. But we can fix that. Now, it's what you've all been waiting for. This. Suppose that a group of people came, each of whom had an infinite decimal number between 0 and 1 on their shirt. Granted, they're going to have to be wearing pretty big shirts. They're conceptual shirts, don't worry. The group of people is so large that there is one person for each infinite decimal series that there is. Now this is a different level of infinity to what we were working with before. For one thing, there's no real place to start because there's no smallest infinite decimal number if you don't count 0. The only thing to do is to randomly choose people and fill up rooms one by one until you get to infinity rooms. Now at this point a thing called Cantor's diagonal argument comes about. You can make up a decimal number from the infinite amount of decimal numbers. You take the first digit of it from the first number, the second digit of it from the second number, and so on. And then you take this new number and you change every digit to get a second new number. Now this is an infinite decimal that isn't the same as the first one because the first digit's changed. It's not the same as the second one because the second digit's changed. It's not the same as the third, and so on. Therefore, when all of the rooms are filled up, Cantor proved that there's still going to be some poor infinite decimal t-shirted sod waiting in the lobby. This is because there are infinitely more infinite decimals than there are rational numbers, or numbers that can be shown as fractions, on a number line. So much so that if you pointed at a number line in any random place, the chances that you would be pointing at a rational number are essentially 0. This proves that the set of infinite decimals between 0 and 1 is bigger than the set of whole numbers between 1 and infinity. George Cantor took infinity and he found a number that was bigger than it. He called it uncountable infinity. Have you gone insane yet? Internet, I'm Tom, and this is the BoffNet, and we're also on Facebook and Twitter. Goodbye! So, 4-minute vlogs, thoughts from places in Dublin, and now the fact that some infinities are bigger than other infinities. This is the BoffNet, where we seem to be ripping off a lot of ideas from John Green.